KCSE revision. We are looking at VectorsII. VectorsII, a question that was tested in KCSE in year 2000, and it was carrying 10 marks. This is Form 3 work. This is normally Form 3 work. So we look at the question. The figure below shows triangle OAB, in which M divides OA in the ratio 2:3. Learner, you read slowly as you fix some figures on the diagram. We are told that in which M, this M here, divides vector OA in the ratio 2 here is to 3. And then you fix an arrow for OA, vector OA. So M divides OA in the ratio 2:3. And N, this one here, divides OB, this vector here, OB, in the ratio 4:1. You fix those figures there. We go to the question, part A. Given that OA is A, small a, this vector OA is small a, come and fix it there, is small a, and OB, this one here, vector OB here is small b, expressed in terms of A and B, learner, vector AN. Where is vector AN? Vector AN, learner, is this one here, vector AN. You can even fix the arrow like that. The arrow should be facing N, or it should be towards N, vector AN, vector AN. So how do you get it? Vector AN, learner, look at this, vector AN is the same as AO plus ON. Vector AN, get this clearly, it's like moving from here to here, is the same as OA plus ON. We write AO, that is AO, plus ON. That is the very first step. So, look at AO. AO, this vector AO, learner, is going against the arrow. It's going against the arrow of OA, which is A. AO is going against the arrow of vector A. And therefore, if it goes against, remember we normally write a negative. We fix a negative there. So negative A plus what? Plus ON. Vector ON is a fraction, learner, of OB. Look at that. It is a fraction of OB. What fraction is it? 4 up to there over 5. That is 4 plus 1, 5. So 4 out of 5 of OB. And so, learner, your AN is minus A plus 4 over 5. OB is small b. OB is small b, as you can see there. And that is your answer. We go to part 2. What is BM? What is vector BM? We go to our diagram, learner. We identify vector BM. BM, fix an arrow in the right direction. BM. So what is vector BM? So you come and say vector BM, learner, vector BM, learner, is equals to what? So like you are moving from here to here. Vector BM is the same as BO and then OM. Look at that. BO plus OM. So vector BM is equals to BO plus OM. I hope you understand that. So look at this, learner. What is vector BO? Vector BO, you are going against the arrow of small b. You are going against this arrow, and therefore it will be minus b. Minus b. Plus OM. What is OM? Look at this, learner. OM is a fraction of OA. OM, learner, as you can see here, is a fraction of OA. What fraction is it? It is 2 out of 5. That is 2 plus 3 is 5. So 2 out of 5. So you come and write it here. 2 out of 5 of OA. which is equals to what, Lana? This is minus b plus 2 over 5. OA is a small a. And that is your answer. If you wanted to start with A, you can talk of 2 over 5A, Lana, minus B. If you wanted to start with a positive one, like that. So, from there, Lana, we go to part B. Part B, to part 2, Lana. You are told that if AX is equals to S of AN, and Bx is equals to T of Bm, where S and T are constants, write two expressions for OX in terms of A, B, S, and T. Then find the values of S and T. Hence, write OX in terms of A and B. It was carrying a lot of marks. Let us look at it. You are told AX is equals to S of AN. S means that it is a fraction. AX is a fraction of AN. And if we go to our diagram here, we can see that for sure AX there is a fraction of AN. And then you are told BX is equals to T of BM. It is also a fraction of BM. BX, as we can see here, is a fraction of BM, where S and T are constants. So we are now told to write two expressions for OX in terms of these letters here. So we look at the first expression, Lana. We look at the first expression. The first expression of OX, Lana, you should use this root. Look at this. You should include this vector. And therefore we go to our diagram, Lana. We talk of OX, you even fix your vector here, there. OX, Lana, OX, this vector here, is the same as OA plus AX. Using that root, we have used our AX. Look at it. OX, Lana, OX is the same as OA plus AX. We write it here, is the same as OA plus AX. I hope you've got that. So we have used our AX in the first root. So this is equals to what, Lana? From our diagram, OA is small a plus our AX here, Lana, is S, small s, of AN. And therefore this is equals to what? A plus small n of what? Small n of small s of AN, and our AN was what? From the very first question here, our AN was minus A plus 4 over 5B. So you move like that, you see this is A, you remove this bracket here, utapata minus SA, you continue multiplying S times this gives you plus 4 over 5 SB. You're just removing the bracket by multiplying with S. So you get that. And so this, Lana, gives you what? There is A and A here. You factor it out. If you factor A out like that, you will be left with what? 1 minus S. Look at that. 1 minus S plus 4 over 5 SB. And that is one expression of OX. We go to the next expression of OX, Lana. Expression Roman 2 there, OX. In this expression of OX, Lana, you have to use this root here, BX. You have to use BX. And therefore we go to our diagram, Lana. If we go to our diagram, OX, Lana, is the same as OB plus BX. Check on that. OX is the same as OB plus BX. We have used our BX. And therefore you come and write, it's the same as OB plus BX. There we are. And therefore this is equals to what? OB is small b plus, what is our BX? Our BX here, we are told that it is T of BM. And therefore we continue and say this is b plus what? T of bm. What was our bm? We got it somewhere. Here we are in Roman 2. Our bm was, you put a bracket, 2 over 5a minus b. Lana, look at that. So this is equals to b plus what? Multiply with the t inside the bracket. Remove the bracket. And therefore this will be 2 over 5ta. 2 over 5ta. Okay? Minus tb. Minus tb. Which is equals to what, Lana? We can start with our a here. The term which has a. 2 over 5ta. Plus this b minus tb. I'm just rearranging so that I start with the term which is starting with a. And therefore this gives you what, Lana? 2 over 5 ta plus what? B here is common. You factor it out. Look at that. So here you'll be left with what? 1 minus t. Factoring out b, you'll be left with 1 minus t. And so, Lana, this is the second expression of OX. So we have the two expressions now. Okay, from there, Lana, what are you asked? At these two expressions, they have the A's, the B's, the S's, and the T's. They are there. So we go to the second part. Find the values of S and T. Yes, you have the two expressions of OX. You have the two expressions of OX. Then how do you find S and T? Lana, we did a similar one in this channel. And we said that if you are told to find these S's and T's, these values here, what you do is that you equate. Look at this. You equate the two expressions. You equate the two expressions of OX, Lana. So you take the first one, you write it here. Look at this. Plus 4 over 5 SB, the first one, is equals to the second one, Lana. There we are like that. We have equated the two expressions of OX. Here they are. The second step, Lana, is that you now equate, look at this, you now equate the coefficients. Let me write it in short like that. The coefficients of A, the term or the figure which is multiplying A. On this side, Lana, this is the coefficient of A. It is multiplying A. You say 1 minus S, you pick it, is equals to what? You go to the other side, Lana. You check for the coefficient of A. It is this one here. It is multiplying A. Those are the ones that we call coefficients. You write it like that. You have equated the coefficients of A. So cross multiply, Lana. Cross multiplying, you'll get these things. This gives you 5 minus 5s is equals to 2t. You can write this equation nicely. You can take through this to the other side, and therefore you can get 5s plus 2t. The other side is positive is equals to 5. We can call that number 1, equation 1 there, Lana. We do the same to the coefficients of B. Equate the coefficients, Lana. The coefficients of B. Equate the coefficients of B. We go back to our equation here. The coefficient of B on this side is this one here. 4 over 5s. On the other side, the coefficient of B is this one. 1 minus t. Again, remove this denominator here by multiplying both sides by 5 or just cross multiplying. So 4s is equals to what? Multiply this, 5 minus 5t. Organize this. Bring this on this side, Lana. You'll get 4s. Taking this to this side, it becomes positive. 5t is equals to 5. Is equals to 5. Call that equation 2. So, Lana, we now have two simultaneous equations that we are to solve. We write them down. You have 5s plus 2t is equals to 5. And you have this other one, 4s, plus 2t is equals to 5. Is equals to 5, Lana. So maybe you can do it by elimination. To eliminate the s's, you multiply here by 4. From one work, you multiply by 5. So multiply everywhere, you get 20s plus 8t is equals to 20. And the other one you get 20s, Lana, plus what? Plus these and these. Sorry, this is 5. Sorry. Let me write it there. This is 5. So this is 25. 25t is equals to 25. Good. So from there, Lana, you fix a line there. You subtract to eliminate the 20s. If you subtract, you get 0. Then subtract this 8t minus 25t. 8t minus 25t gives you minus 17t is equals to what? Do the same on this side. This minus this gives you minus 5, Lana. Do away with the minuses. Then divide by 17. Divide by 17. Your t, Lana. Your t, Lana will be 5 over what? 17. That is your t. Just solving simultaneous equations. Then take this now to get s. Take to the original ones here. You can use the first one here. So we can talk of 5s plus 2 in bracket. Our t, Lana, here is 5 over 17 is equals to 5. We substitute here to get our s. So this gives us 5s plus what? Multiply this 10 over 17 is equals to 5. So Lana, you work out this. You can decide to remove this by multiplying area by 17. Multiplying here by 17. Multiplying here by 17. By 17 there. By 17 to make your work easy, you would get, here you'd get 85s plus what? This and this would cancel out. The 17s would cancel out. You remain with 10 is equals to 5 times that gives you, gives you 85. Gives you 85. Yeah, that is right. Gives you 85. So 85s, Lana, is equals to 85 minus 10, and therefore 85s is equals to 75. And therefore to get s, Lana, you just divide like that. So this cancels out. So what is your s, Lana? What is your s? Simplify this. By 5, by 5, 15, by 5, 17. And therefore your s, Lana, is 15 over 17. That is the value of s. From there, Lana, we go to the last step. We are almost there. What are we told here? We are told, hence, after finding the values of s and t, hence, write ox in terms of a and b. Write ox in terms of a and b. So what you do, Lana, in this case is that you take your this expression or the second expression of ox, you take it. Let me write this one here. Let me transfer this. So you have ox is equals to 1 minus s of a plus 4 over 5 s of b. I've taken the first expression. Come and fix your s. Your s is this one, Lana. Come and fix your s here. 1 minus 15 over 17. What? A plus 4 over 5, 4 over what, 4 over 5 times 15 over 17 b. Okay, so from there, Lana, you work out this. This minus this would give you 2 over 17 of a. Plus, you work out this by 5, 1, by 5, 3. This gives you 12. 12 over 17b. And this is the expression of ox in terms of a and b. Lana, You can as well use the other expression of OX, the second one. Go and use the second expression. This one here, let me show it to you. You can use this expression. You now fix your T. Fixing your T, learner, you will still get the same thing. You will still get this. So learner, all the best as you practice on vectors too. These problems are very important. They normally carry 10 marks. I wish you well in mathematics, learner. Practice makes perfect. God bless you.